All right. And now I'm going to take you to the present. I was going to say the future, but this is actually what we're doing right now. So the state of the art of energy efficiency design of buildings. When you want to make a building a zero carbon building, independently if it's a new build or if it's an existing building, there are some 1,000 different things you can do to make that building more energy efficient. And each of these 1,000 products and services, they have a cost and they have an impact on the building. And when currently in the green transition, when we want to make buildings carbon neutral or zero carbon, it's never enough with just one or two things. You have to do many things at the same time. And when you do many of these different energy efficiency measures at the same time, they also affect each other. So to really calculate, if we pose the question that what is the best, really the best way to make my building more to make my building carbon neutral or more energy efficient, and you want to have really the right answer to that question, that means that you would have to do a lot of calculation, both energy calculation and financial calculation. And it's so much work that it's actually not even possible to do for a building. There is so much, if you want to really do it, if you want to really know what is really the best combination of energy efficiency measures for this building, how can I get the maximum return on investment, or what is the most cost efficient way to get this building to energy class, energy EPC rating, energy class A, or something like that. So therefore, we have created a software to do it. And for the software, it's easy. It works in a way that first, always, we start with the energy simulation of the building, where we make a perfect digital twin of the building. And when we have done an energy simulation, we do something we call re-engineering of energy flows. And this is what is new. Energy simulation softwares there are, but re-engineering of energy flow softwares, there is only one, and that's this nolla software. Re-engineering of energy flows means that when we have done the simulation and we know the building, we know how the energy is flowing in the building, then we do calculate what should we do with this building? What different things should we do out of all of these different possibilities that you have available? Which ones done together give the best outcome? That is what we call re-engineering of energy flows, and it means actually that what the software does is that it calculates all of them through. And when it has calculated, for instance, for a office building, there can be 100,000 possible combinations of energy efficiency measures. Then it shows which one out of these 100,000 combinations gave the best outcome. What are the things you should do? How should you do them? What is the cost of doing them? And when they're done, what is the outcome in terms of energy consumption, energy rating, if you have some kind of certification, like you want to make a LEED or LEED certification for some building or something like that. And carbon footprint, and of course finances. And the simulation, it starts with the 3D model of the building. We draw the building, the user of the software draw the building exactly as it is, right as it is in the blueprints of the building. All the walls and windows and doors and all that stuff, but also technical details such as every radiator that exists in the building, and also every ventilation unit, and for ventilation units, even what parts does the ventilation unit consist of. For big ventilation units, like if you have a central ventilation unit for a building, the software wants to know what is the manufacturer and model of the supply air fan, what is the model of the exhaust fan, what heat recovery is there, what is the manufacturer of that one, and which model, and so on. All the different details of the ventilation unit. And when all this information is in the software, then it calculates 1 hour at a time the whole year through. And after that, it shows where the energy is going, where the energy is going, when, and how much. This is the first step in the process. This is possible to do also with other softwares. There are, I think, the most used softwares currently in the world are Energy Plus and Open Studio softwares like that. They give exactly the same numbers as our software. So here, this is not new, this simulation part. But what is common for all the softwares, the energy simulation softwares, is that they start in this simulation and they also end in the simulation. So they actually tell you what is the situation right now with the building. What the innovation that nolla has done is that the software does not only tell you what is the situation right now, but it can also tell you what to do about it. That is the new thing. And that is what we call re-engineering of energy flows. And this means that when we have done the simulation, we know the situation before. Then the software starts making a new energy simulation, but it changes something in the building. And when it has calculated every hour of that year, then it starts again, but changes something else, and goes on for hundreds of times, and for bigger buildings, 1,000, because that's the amount of different things you can do to make the energy efficiency better in a building. After calculating them separately, it starts combining them, and then again calculates for every combination the whole year through, 1 hour at a time. And when it's done, after calculating 30,000 to 100,000 times, 1 hour at a time the whole year through, then it shows which one out of these 100,000 combinations was the one that gave the best return on investment, or the smallest, the most cost-efficient way to reach LEED Platinum, or whatever the case is. Most often, it's the return on investment for property investors in Europe currently. Yeah. Did you have a question?
Yeah. So at least in my experience putting together some energy efficiency forecasts, initially the low-hanging fruit in energy efficiency is typically changing light bulbs or making sure the appliances are energy efficient. And it takes quite a lot, I think, to get to the 100% efficiency, because the last few things like 10% or 20% either take a while or would need more cost investments and such. So is there anything that nolla E as a software that focuses on that last 20%, or is there anything that you can talk to me more about, not only the low-hanging fruit, but what about this remaining piece?
Yeah, this software changes. When you're talking about doing one energy efficiency measure, for instance, changing the light bulbs, then it works like that. The low-hanging fruit is to change the light bulbs. But when you use the software, and the problem with changing the light bulbs is that they will not make the building carbon neutral. They will save some energy, but somewhere around 5% or something like that. What happens with the software is that you don't get a low-hanging fruit like that. You get a new low-hanging fruit, but that saves 80% of the energy that the building consumes. Of course, the investment cost is bigger, but it gives you a very profitable, very high return on investment, and that can be also called low-hanging fruit, because now you previously you got the low-hanging fruits for small things that are profitable but don't make a difference. Now you can have one big low-hanging fruit that actually makes a difference for the building, makes that building zero carbon. It's of course a bigger investment and bigger. It's not one thing. There is like 20 or 40 different things that done together add up to this. And if you look from the point of view of these typical low-hanging fruits, like changing the light bulbs, those might be one part of the solution. And the software automatically calculates what is the cost of doing them and what is the return when you do them for the whole building. Change all the light bulbs and do similar things. And also there will be other things that are not commonly known low-hanging fruits, but usually kind of a little bit more special things. On this slide, we actually have a like a case study. On this slide, we can see the peak heating load of this residential apartment building. This is residential apartment building built in the 60s, 36 apartments located in southern Finland, next to Turku, the third biggest city in Finland. And their initial, like the starting point was that they had oil heating in this residential apartment building, and they wanted to switch the heating source from oil to something else. And in Finland, if you want to switch oil to something else, the typical alternatives are district heating or geothermal heating. And they had asked for offers for both, and they had decided that they're going to go further with the geothermal heating. And they were also on the way to acquire the system, which is a long process for a residential apartment building, because all the owners of apartments want to be involved and have to make votes and all kinds of stuff. When somebody on the board said that, hey, let's have a timeout, because this geothermal system, it costs 493,000 euros, and none of us know anything about geothermal heating. I suggest we hire a expert to make sure that we do this the right way. And Nolla became involved in the project, and the outcome was geothermal heating. But on top of geothermal heating, we did 19 other energy efficiency measures that lowered the energy consumption and also made the indoor air quality better. All these together, these 19 energy efficiency measures and geothermal heating added up to 467,000 euros, whereas only geothermal heating would have added to 493,000 euros. So this means that we get a more energy efficient building, we got better indoor air quality, and still the investment cost was less. Usually in energy projects, you pay more upfront and then you get energy savings and then you get a payback period. But in this case, making superior energy efficiency was already in the investment. It was had a smaller cost. How is this possible? This actually has to do with this peak heating load of the building. In Turku area, the peak heating load is calculated by minus 26 degrees Celsius. You use Fahrenheit, but minus 26 degrees Celsius, that's really cold. And in the starting point, the peak heating load was 288 kilowatts at the minus 26 degrees Celsius outside ambient temperature. And if they would have done nothing else with the building, but switched from oil to geothermal heating, they would have needed to invest in the 288 kilowatt geothermal system. And a geothermal system, 288 kilowatts, costs 500,000 euros. Whereas here, after optimizing the energy efficiency measures and finding the right things to do, the peak heating load was only 100 kilowatts, because these other 19 energy efficiency measures, they make the energy efficiency so much better that the peak heating load was only 100 kilowatts. And a 100 kilowatt geothermal system costs only 1/3 the cost of 288 kilowatts. Actually, in this specific case, the cost of the geothermal system was 140,000 euros. And with the difference, 353,000 euros, we did all the other energy efficiency measures. And after doing them, there was still 26,000 euros left unused, despite getting better energy efficiency and better indoor air quality. But the big thing with this is the life cycle cost. If they would have done nothing with that building, they would have ended up paying 2.3 million euros for the upcoming 20 years. By switching from oil to district heating, which was one alternative for them, they would have lowered the total life cycle cost from 2.3 to 1.7. So that would have been okay. They would have actually saved 580,000 euros. And with the geothermal system that they were going to invest in, they would have lowered from 2.3 to 1.3. So they would have almost saved 1 million euros. But now, when we did it this way, we are one more step lower in life cycle cost. We get, with a 26,000 euros smaller investment, we got 550,000 euros bigger return. We have actually this in numbers here. Do you have some kind of energy class in Minnesota? Energy rating for buildings?
I'm sure we
like
do.
A LEED? Yeah, like a LEED certification, you mean, or?
No, LEED is voluntary, and it's like in Europe there is like you have to have, for every building you have to have an energy certificate that tells if the energy efficiency of the building is A, B, C, D, E, or F, or even G. I think the worst one is. and it's calculated. It's a standardized procedure how it is calculated, and it is so that you can compare the energy efficiency of one building to the energy efficiency of another building. Now, excuse me, I have to quickly get some energy to my computer.
I just Googled it, and looks like there is a rating system which is HERS for residential buildings, but then the Minnesota DEED website says that they are working on large building energy benchmarking. So maybe there is no real rating system for large buildings. But we could research this if needed.
Yeah, that's very interesting because this energy rating of buildings, it did for 5 or 10 years ago, it wasn't that important. But currently it's very important because it's actually it has an impact on the value of the property. Also in the EU we have this green finance, and if you have if the building is green, you can actually have you get better terms for loans, mortgage, and there's a lot of benefits with having the better energy and EPC rating.
Yeah. I was actually reading on that Commerce website. Actually, the energy benchmarking program requires owners of large commercial and multifamily properties to submit whole building energy usage annually to the state of Minnesota. So it is a program. I don't know how they use it, but
Okay.
There is a system to report that.
Yeah. Okay. That's good. That's a good start, because that's I think because it standardizes how you see energy efficiency, it makes actually buildings comparable. Now the first case I showed you was this existing building built in the 60s, residential apartment building. Now I will present a very different type of building. This is right in the city center of Turku, which is the third biggest city in Finland. We have a big market square right in the city center. And underneath that market square, they started building a 2-store parking facility like 8 years ago. And that project also came to us in 2018. And by then there was only architectural drawings of the parking house and a carefully mapped like a map of constructional piles, because the city of Turku is built on clay. And right here underneath the market square in the city center, there is 50 meters of clay. So all the buildings built there have to be built on piles. And constructional piles are expensive. But if you have 50 meters of clay, they are very expensive. So already in the start of the project, when they had the architectural blueprints, they also had mapped every pile, what type of constructional pile, how long is it, what is the thickness of it, and so on. So and where they are and so on. So we got those as like information in the start, initial information. And then there is on this parking facility, they have been built for restaurants and cafes, coffee shops. We also got architectural blueprints of them. They are one here, two here, and one this side. And then there is also commercial spaces built underneath the streets next to it. For instance, here is a big supermarket. So we got also architectural blueprints of them. And then there was one very special thing with this project was that the city of Turku wanted the market square to be kept non-slippery in winter. And those were the initial information that we got. And here is how we put it in the software, and here is how it became. The city of Turku is supposed to be carbon neutral by 2029. Here is the market square. Here are the cafes and the restaurants. And in order to keep it non-slippery in the winter, we have pipes installed underneath the pavement where we circulate warm water in the winter, and it melts the ice and the snow. Here is how the market square looks like. Here are the cafes and the restaurants. And what is special for this project is that we use the same pipes also in the summer, currently, right now, actually. When sun is shining and warming up the pavement, it also warms up the water in the pipes. Here are the pipes. And it warms up the water in the pipes to somewhere around 40 degrees Celsius. And since nobody needs 40 degrees Celsius thermal energy in the summer, we save it for next winter by circulating the water in the piles, constructional piles that the building is built on. Here we circulate this 40 degrees Celsius water the whole summer, and slowly the clay, 1 million cubics of clay, start warming up, so that next winter the clay is so warm that we can, by only using the thermal energy in the clay, warm up the parking facility, these cafes and these restaurants, and also keep the market square non-slippery. And the only energy we use in the system is circulation pumps. They use a little bit less than 1% of the energy that they are in the summer collecting from the surface and put it in the ground, and then in the winter retrieving from the ground and warm the buildings up and also melt the ice and the snow from the market surface. This means that we have actually lowered the energy consumption of these 8 buildings by 99%. And that is carbon neutral. Here are also the numbers of this project. This is a quite big, it's called seasonal thermal energy storage. This, when we store the thermal heating energy into the ground and use it next winter. And in 2019, we actually wrote some scientific articles about this project, because by then it was still the biggest of its kind in the world. Not anymore, though. There is in China and Denmark, there are bigger, and probably even other places, but 2019 we were still, this was the biggest. The thing with specifically in Nordic, when you live in the north, you have, like you also in Minnesota, you have warm summers and you have cold winters, and one of the ways how you can really warm up buildings without using any fossil fuels at all is to store the thermal energy from the summer and in a way so that you can use it next winter. The cost of this system was 6 million euros. But we applied for, and we also got subsidies from the government for new technology, 1.3 million. And also, since we built this system, there were other initially designed like things that were not needed anymore. So like the net cost of this system was somewhere around 4 million euros. And the annual return has been 838,000 euros. So it's quite good. It's quite profitable considering that this system is pretty much, it doesn't need any service and maintenance. It's very simple. It's just plastic pipes in concrete and a couple of circulation pumps and some heat exchangers. A very simple system. We don't use heat pumps, for instance, here. Only circulation pumps. And then one other type of buildings that projects that we do a lot is these where we use waste heat from one building to heat another building. For instance, here is a big shopping center that we were designing in 2019. When we did the energy simulation and put it in the software, we found ways to lower the annual energy consumption from 4.8 gigawatt hours to 1.6. So we lowered that by pretty much 70%. But why we call this shopping center carbon neutral is that at the same time, we also, the same builder who built the shopping center built 5 residential apartment buildings next to it. And the 5 residential apartment buildings are designed to be heated to the extent of 97% by waste heat from the shopping center. And if we take the initial design annual energy consumption of the residential 5 residential buildings and subtract that from what was left when we lowered the annual energy consumption to 1/3, we are very close to zero in terms of megawatt hours, in terms of carbon footprint, and also in terms of financial, because they are currently we lowered the annual energy cost from 400,000 to 170,000, but since the shopping center is selling the waste heat to the residential buildings, so when we take into account the revenue of selling the waste heat, we are close to zero, which means that with an additional investment in the construction phase of 580,000 euros, they have close to 400,000 euros in return annually, which makes it very, very profitable. And why there is so much emphasis on the numbers is that we are trying to get like property owners and developers to understand that this the green buildings are not a cost. They are actually a possibility to have a lot more profitable and valuable buildings if you do it the right way. It's a possibility, or what do you call it, opportunity to have a lot more valuable buildings and a lot bigger yields. Actually, we have one more good example of, here is in this shopping center we did the same thing, but this is an existing, whereas the previous was a new build. This is an existing shopping center, and next to this shopping center there is a huge residential apartment building that is heated by the waste heat from the shopping center. Shopping centers, they have a lot of waste heat because they have the cooling systems, and then if they also have, which they usually have, they have supermarkets and stuff like that. They have like there is waste heat not only in the summer but also in the winter. But then about the value of property, here is a good example of this is a commercial property that has also a medical clinic on the top floor that we did in 2019. It's right in the city center of Turku, next to a boulevard, like a walking boulevard. So it's like the really a number one what do you call it, location in the city, which means that these buildings in right in the city centers, they are sold, were sold with a 5% yield. And this building owner was going to sell this commercial property. They already had, or actually the buyer for it. It was a German fund, and they were going to sell it. But before they sold it, they bought, ordered us to do this study for this property, and we found energy efficiency measures that added up together for 157,000 euros. And by doing those, investing that 157,000 euros on these different things to do there, they would get a 65,000 euros annual smaller energy costs, which means 65,000 euros better yield. And if you get 65,000 euros more yield and you sell the property with 5% yield, that means that they got 1.3 million euros more for the property when they sold it 1 year after that. In 2020, they sold the property. So 2019, they invested 157,000 euros in doing these different things that we did. And 2020, they sold the property for 1.3 million euros more. That's a very clear connection between the energy efficiency and the value of the property. Yeah, I think that's pretty much. We have very many different kinds of buildings where we have done these, like we have these, what are they called? They are called old buildings that are so old that you're not allowed to change how they look, not even inside. Protected or something like that. Those, of course, do not turn into carbon neutral buildings, but still there's a lot to do. You can still lower the energy consumption to less than 50% anyway. So also they are very profitable to make changes to. We have also worked in like different conditions, for instance, in wait, no, this is the. We have also worked in warm countries. We have examples of that, and a funny fact is that in warm countries, there are quite often actually the energy consumption is actually bigger, but it's not for heating, it's for cooling. But the energy consumption is bigger. And also then the things that we do are very profitable also in warm countries. They are just, of course, different since we are saving cooling and not heating like we are in the Nordic countries. This is a hotel in Doha in Qatar. There was actually 20 of these made, and this was for the football championship in Doha that was some years ago. These were made before that, and yeah, the conditions in Doha were 35 degrees Celsius ambient temperature every day, the whole year, and sun shining really strong from right above. And then Maldives, another project, a little bit different. This was an island that was artificial island that was made there, and on this island there were 60 of these villas built, and yeah, also there how the initial design would have led to annual energy costs of 3,500 euros for one of these villas. And the combination of energy efficiency measures that we found lowered that to 78 euros. That island, of course, did not have any kind of electricity or energy source, so all the energy had to be there was like a boat with diesel oil that went there every day with full of diesel oil, and then there was these huge diesel generators that would make electricity. And after making these villas energy efficient, there was like a totally different type of consumption, even such that you don't need to have diesel anymore, because diesel you only need if you use a lot of energy. Then you have to have diesel because it's has a lot of energy in it. But if you lower the energy consumption to a very low level, then you might be able to do it with on-site energy, for instance, solar panels, instead of shipping diesel. Yeah, we have calculated very many different types of buildings, offices, commercial property, old buildings, new buildings, and different countries. Yeah, any questions?